Awesome. As he said, we've known each other from high school, so I appreciate, Brian, that you left out some details that would be less validating and may make you question sanity. My name is Eric Wooldridge, professor and director of the Additive Manufacturing Center for KCTCS. And what we do is 3D printing. So as soon as we get some slides up, there we go. Our goal in 3D printing the technology is to take it and put it into the workforce and create the innovations that come with it as quickly as possible. We are located at Somerset. We're part of that 16 community college system. And our driving force is the technology to benefit from it in many different ways. Part of our plan and part of our approach is to teach teachers how to do it. So we make the content and then we train them. So we've taught about, or trained about 250 teachers across the state. We're in about 186 schools, and now we're going national, using the technology to make benefits. And the reason we're working so hard for this particular technology is because of its advantages. And for those of you who are not super familiar with it, you may have seen it in schools or your kids are using it. It kind of boils down to this. Normally or conventionally, when we wanted to make something, we would take a block of material and we would whittle down until we had a part. And with 3D printing, it's the exact opposite. We take material and lay it down layer by layer and grow from the inside out. So we can do this in metals, we can do this in plastics, we can do it in all sorts of materials, including concrete. But 3D printing is not about the 3D printer. 3D printing is about the shape that it can make. I also use this kind of as a demonstration. 10 years ago, if I had gone to a manufacturer and said, hey, I want to make this part, they'd say, awesome, we can totally do that. And I'd say, great. But now we're in a world where sustainability does matter. Less material consumption does matter. And so here's the same part. It's got a few more holes in it, but it's a better solution. A little bit lighter, a little bit less wasted material. And I would ask them, and they would say, you know what? Kind of scratch their chin a little bit and say, yeah, I think we can build this for you, but here's the catch. It's going to cost you. Typically, complexity, typically more sustainable things require more cost. But now we're in the world of AI, and AI says that this is the ultimate solution. It is the perfect solution. Iterations, thousands of times in just a few minutes, have led the system to design this particular design for the part need. It is the least amount of material you need to use, and it's very structurally sound. I go to the same manufacturer and say, I want to make this, and they would say, I'm sorry, we can't make that. That's just too organic, that's too complex, we just can't make it happen. And yet it's the perfect solution. So what do we do? Fortunately, nowadays we have technology called 3D printing that will make this all day long. The printers in your kids' classrooms can print this and not ask a question about it. That's the point of the technology. It's not the printer, it's the shape. So many companies are already using this technology. You have flown on 3D printed parts that sort of look like this. This is actually parts that go into BMWs. And the same thing is true for concrete. We can take that same concept, that same technology, and do it in a way that is next generation. So what you're seeing is a concrete 3D printing process. This is actually what we're building out at the lab. It's a new type of retaining wall for flood control and also landscape control. You'll notice a couple of things. First of all, there's no forms. There's no rebar. And look at the shape it's making. The same thing we've been doing for the last decade in 3D printing, it's just out of concrete and it's bigger. So the reason we're doing it, though, is because of this. This was last May. I was on the ground, of course, another series of tornadoes come through Kentucky. I was on the ground this Saturday morning evaluating structures at the London airport and documenting the damage. Documenting why the things collapsed. And here's the catch. We know exactly why things fail in high winds. We already know the engineering. We just confirmed it on site. Truth be told, we've known this for years as to why things fail. We have computer models for days. We have full understanding of why this happens. We even have cute little graphics that we can show folks that say, this is why your buildings fail. We have multi-million-dollar facilities across the nation that actually build things and then test it in high winds. So the point of this is why does it keep happening if we understand it so well? If we understand the science behind it, why do we still have failures? And the truth is, we still have limitations in what we can build. Because if I can design the perfect solution, but you can't go to Lowe's and buy the parts to do it, then it doesn't do us any good. So with that knowledge and that understanding, it doesn't matter if it's a wind or a flood, whatever the case may be, in 2022 we had the actual troublesome creek floods. And that resulted in action being taken. We were approached by the USDA and the ARC to address this particular issue. 80% of the structures that were damaged or destroyed in that particular flood were actually outside of the target flood zones. And yet we have to rebuild. And so the question that they posed to us was like, we know all this information. Can we do something about it? We've been working with you in 3D printing for years. We've been seeing these things where people are concrete printing, 3D printing structures, robots making houses. Can we use this technology to do something about it? And the answer was yes. Is there a way potentially to make a bunker and disguise it as a pretty house? Comfortable from the inside out? And the answer is yes. Is there a way to actually make it compliant with building code enforcement? The answer is yes. So we got started in the process about 2 years ago. This is our first printer system. It's about a 5-year-old piece of technology, going through the process of figuring it out. Using really expensive equipment there to analyze things as we did stuff and just kind of play with it. See what shapes we can make. See what goes wrong in the process. And there is a lot that goes wrong in those early days. This particular piece of equipment, unfortunately, requires multiple semi-trucks and a huge crew to actually get it set up and get it going. But it did teach us this. It showed us that we could create the shapes that could take the forces. It could create that organic design that you saw in the other pieces earlier on. It could do what the AI says is the best possible solution. We could finally have a chance to take this advanced technology that we have and turn it into a solution that we could create. So for example, what we came up with is a solution to this kind of problem. Most of your homes in a flood situation or even a wind situation, they fail at the connection points or the corners. Corners collect stress. And so what we came up with is what we called the Floodbuster design, a design that was actually named after the nature of the grant that we'd received. And you can incorporate this type of design into the corners, into the key points of a house. And no one will ever know it's there. You just print it within the wall structure. And so the Floodbuster design was a possibility that we realized could be done. Of course, the question comes up with is, even though we might be able to do it, is this really scalable? So the question comes up, is this commercially viable in this process? So what you do is you look at see where things are happening. Walmart, for example, this is actually expansion that's done. This is actually the number 2, and you can see pictures of it, just printing walls. There's the final product. Walmart is, of course, expanding because of the COVID need to have the pickup options. And so now they need these new wings. And so it works, but the proof is the fact that Walmart has another 12 of these planned out. 5,000 square feet, 20-foot tall walls, printed in 6 days. They roll up and they're done printing by 6 days. A new form of technology that we've never had the option to do. And we can't compete in terms of conventional construction. And that 12 more sites is the proof that it's going further. It's not just Walmart, it's other big box stores are looking at the technology. So the next step for Kentucky, of course, would be, let's do it. We know it's real, we know we can do it, let's go ahead and create it ourselves. And so a couple months ago, back in June 27th, we had what we called Floodbuster 1, where we 3D printed in concrete Kentucky's first house. And we did it in such a way that was, viable and had meaning. So we worked with Habitat for Humanity and took one of their plans that's about 800 square feet, and we optimized it for the Floodbuster design and started the process. But we realized we couldn't just turn around and do it and just print a house and just say, hey, everybody come look at this house. We had to do it live so that people could see it in real time and see that it's a real technology. So the machine rolls up and you start printing. In fact, this is actually what you want to see. You want to see my guys sitting around in chairs eating a sandwich while they're running this machine. That means we've done everything right. We've been able to do the engineering and the planning and the things that matter so this thing assembles like a Toyota Camry in Georgetown. You can also see some of the complex geometries we build into the shape of the wall, unique to its situation and the forces that we want it to resist. You can work at night, you can work in the day. Machine doesn't seem to concern itself either way. We even were able to bring in some of the trades that go with construction. This is actually the 1032 Cement and Plasters Union out of Cincinnati. They came down to demonstrate the type of finishes they can add to a concrete 3D printed house to change the look. You want to make it look like a Grecian monument? You can. Tuscany villa? You can. All the while having a structure that can take the next hit. So the process went well. You can see the Floodbuster there in the corner. And we were able to get the work done in 6 days. Kentucky's first house, a good start. But what was interesting from the process is what happened after that. There were other places that had 3D printed houses. You may have seen this on 60 Minutes. The difference that we found, though, afterwards is because we weren't a company that was trying to sell you a printer or a construction company, more people reached out and just said, hey, what can we do? How can we start doing this and scaling this out? So we have about 5 houses going up right now in Ohio with a company called Vitruvian. And we have requests for new designs in both the Floodbuster series and the Stormbuster series. This is actually new shapes and renderings that people are requesting. This is actually Floodbuster 2 that's going about 5 miles down from my lab at the Bluegrass Veterans Ranch. And people are interested now. This is the Stormbuster series, 2-bedroom, 1.75 bath that's targeted for Oklahoma. And the question always comes up is, what's the numbers? How viable is this? So Floodbuster 1, about 6 days to print. More than likely, we could probably get this down to about 3 or 4 days with a little bit more practice. Took about 10 yards of concrete, 10-foot tall walls on one side, 8 foot on the other. And we engineered the walls for an EF4 tornado or a Class 4 flood. But there's more data. This is actually a group out of Canada that's been doing some great testing. Because we always get asked, how strong is it? And I usually respond with well, it's concrete. But the truth is, you can get a tremendous amount of strength. An unreinforced concrete wall was proven to be able to take about 85,000 pounds per foot of wall of compression strength. Your typical wood framing can give you about 4,000 pounds. In shear situations, and so if a wind blows against a house, like on the gable end of a house, it's the side walls that are actually resisting that push, not the gable end. So it's a shear wall design, and so they did a wood test to show the difference. About 3,000 pounds for wood, over 11,000 pounds for concrete. So the strength is there. It's been proven out for several years. Army Corps has been doing tests on this since 16, I think. And the question always comes up is, well, let's talk about energy efficiency. And this study was already done. It targeted the different regions across the U.S. We're, of course, in, basically our climate zone is 4. And you're looking at anywhere between a 20 to 30% savings in annual energy costs because of this wall design and these structures. And it's not always what you think it is. It's not just a pure R factor. It's the infiltration sealing that it does because it's a robot. It doesn't miss. It doesn't leave little gaps. So the other question was, well, look, what's happening out there because of this? And globally, there's a lot of houses being printed. Here in the U.S., we have our 5 mentioned in Ohio, another 10 Virginia Tech's doing. Icon's got about 100. Colorado has several projects in the making to total up about 520 by 2029. We're doing about 5 test runs in Arkansas right now with another 400 planned after that, and Alquist has about 200. Now, don't get me wrong, though. We're in a housing crisis of like 3 to 6 million houses we need. So these are small numbers comparatively speaking, but they are numbers, and they are showing that it's viable and it is growing. This is the big one. Everyone always asks, well, how much does it cost? They always ask for a cost per square foot, and the truth be told, you couldn't get a cost per square foot because the builder's always going to say, hey, well, what do you want? The same thing's true here. Most of the 3D printed house is still conventional things. Your toilets, your sinks, all those things are still the standard. So the best way to describe it is this. If you take the most low-cost construction you possibly can, 2x4 walls, vinyl sided, thin sheathing as you can get by with the residential building code. You take that cost, and then you compare that cost to a little bit more moderate, 2x6 walls, brick siding, a little bit more finishes, and you take that cost. And if you look at those two cost differences, we're about right in the middle. So it's affordable. Now, we're probably never going to beat the lowest cost, the 2x4s and thin walls, because it's just too thin of material. But truth is, this structure is probably going to last about 30, 40, 50 years, and then going to be demoed. We see that all the time in developments, where a concrete printed house is probably going to last anywhere between 100 to 150 years. So it is a game changer in that sense too. But it does come with one other major opportunity for Kentucky, both in terms of sustainability, environment, and energy. And that is this. You sat on plenty of these in parks, in municipalities. You may have put one of these in your backyard for your new house. We've seen these day in and day out. They're concrete products that are conventionally made. In fact, actually, they're made the same way the Romans made them back in the day. We really haven't changed concrete that much in 2,000 years, at least how we put it together. But the technology allows us to do the same thing with concrete printers. So for example, the same printer that I use to go out and print Floodbuster 1 can be pulled back into the shop at night and start producing concrete products. And you'll notice the shapes are different. So we called up if you're familiar with the SOAR conference, it was down in Corbin this year, and we called up Josh and just said, hey, you want us to print you some furnishings for the event? And he said, sure. So 24 hours after that conversation, they exist. No forms, no muss, no fuss. And you can see the shapes. We're just doing some things like a podium, some benches, simple shapes they could use. But you can see the design of them is different. Now, when you are introducing new technology, it's always important to have an influencer kind of get it out there for you, a celebrity. So we got this guy. He seemed pretty trustworthy to share this about. I don't even know if he knows he's promoting it every time, but he was. Kentucky's first concrete printed podium, which I'll say that all the time now because we're the first of anything at this moment. So using that technology, we can create things right off the bat. Any design, any shape. And aside from having way too many pictures of our governor on my computer, it turned out to be a really good way for us to get things out there. So everyone who took a picture at the event was actually promoting the technology. And the cool thing about this, many of these things take less than an hour to print. And they use less material, less concrete than you can conventionally construct. And they also introduce a new way of design and branding, if you want to. It allows us to take ideas from mere sketches and turn them into reality that afternoon. So it also allows us to embed components, electronics, and features into the production while we're printing. We do a lot of art and engineering at the same time. allowing us to create shapes that are optimized for folks, never having to build up infrastructure because we don't use forms, maximizing the opportunities. These are actually designs we have in plans for new types of foundations for homes and retaining walls and water control systems. This is a design concept we have for coral reef creation. Ag tech products can be totally reimagined. Let me tell you, farmers have great ideas. We come up with some weird stuff when we're trying to fix something, and having a machine to turn around and make it for us like that, game changer. Again, we've had concrete for 2,000 years. We've never been able to do what we can do with it now. And it's not just the fact we're making things out of concrete. You know, with the request for storm shelters obviously has come up. But I can print a storm shelter for sure. But unlike a standard storm shelter, which is usually just a big box, and it, through brute force resistance, you know, accounts and protects people from the forces, we can shape the concrete so that the wind exerts less force on it to begin with, and then make it even stronger with concrete on the inside. Again, just unbelievable what we can create now. So next generation infrastructure made by municipalities right on site with their own highway maintenance departments is possible. All the culvert problems that we're having, all these issues of water control, the lack of funding to repair all this infrastructure, because we have concrete and we have people that can run machines, which means we can actually solve our own problems and turn around and create new types of exports. Not only that, we can design them to be better for their situation, more organic in nature. As we know, organic design is better. So when you come by the lab, you'll see some really weird looking stuff, but stuff that actually solves a problem. New shapes we could never make with concrete. Most of the time, there's no steel reinforcement in it whatsoever. Really weird stuff, I assure you. So it is a new way of thinking, born from what we've been doing in 3D printing for the last decade. This is just adding on a new material, a little bit bigger. So our next steps, of course, to teach people how to do it. As part of the AEMC's work, we are scaling out new courses and workforce training events for companies who want to learn how to do concrete 3D printing, and municipalities that want to learn how to do concrete 3D printing. And the other part of it too is this, is public-private partnerships. Our new president, Dr. Quarles, is really focused on the community colleges being able to engage their communities and their businesses locally to do things. And so what we're after are folks who want to try new projects in concrete. We'll figure out a partnership, we'll figure out a deal, whatever the case may be, because we need to get started on this now because the technology is good enough. It'll keep getting better and better every 6 months, but it's good enough to do what needs to be done. And kind of to wrap it up, finish it with this thought. Qatar has plans right now to do 2 schools, 65,000 square feet apiece, that are totally 3D printed. They actually have a little bit of lead. They've been doing this before us. But the capacity is there. The equipment's there. The people are right here ready to do this. And these are things that we can be doing right now and going forward. So to kind of wrap it up a little bit, if you're interested and want to learn more, you can take a picture of this slide here. This actually has our social media where we post out a lot of the stuff that we're doing and how you can reach out to me to engage. Because we need to do projects, and this is the time to do it. It also looks like I got about 5 minutes according to my time here. So we'll check and see if we've got questions. Whoa. Okay, question number 1. Can this process be used for other environmental concerns such as earthquakes? Yes. Now, seismic performance of concrete is different. However, we do have the analysis and the process to actually design in structures that can be seismic resistant, because it's just a force like everything else. Does insulation go in between the walls like in a conventional wood home? Yes, it can. What's interesting, though, is that we actually can make a concrete wall have air gaps in it that form their own R values. So I can add more insulation in, or I can have the concrete achieve an R value if I want to. We have a company that's actually got a special foam that they use particularly for concrete printing that can achieve like an R50 wall value. You don't really need that much kind of capacity, but you can achieve it. And of course, the cost versus conventional wood construction, kind of addressed that one. And can you build a 2,800 square foot home with a basement? Yes. Turns out because the printer, so the big gantry you saw at the very beginning, that was our 5-year-old piece of equipment. Cost about $1 million. The one we have to do Floodbuster and the one we use to make the podium cost about $500,000, and it's a robotic arm. The one we're about to get that's more scalable is going to be under $200,000. So the equipment costs are coming down drastically. But the most important part is it's just a robotic arm on a bobcat set of treads. So you just keep moving it and print another wall, and you move it and print another wall. So it's actually unlimited in how big it can print. The basement wall is a little bit different, though. That requires a little bit different design kind of process. So we're really focusing on above-grade walls, and maybe 2 stories first, and then some basic foundation walls before we get into too much basement. But it is coming here shortly. And that looks like it. Any other questions from the audience that I can answer? Yes, sir. Not always completely eliminate. The question is, like, does it remove steel completely? The answer is kind of yes and no. Most of the time, we will design so the concrete is not in tension, and so therefore we don't need it. But there are cases where we'll actually do some reinforcement to create like collectors. So it greatly reduces it. It is a more recyclable concrete, though, because we do use much less steel. So you can just essentially grind it back up. But we still have a mix. Yes, sir. Mm-hmm.
Concrete would have to be obviously very precisely mixed. Is this something just typical run-of-the-mill concrete companies carry?
Sure. Well, if you ask them, it's something very special, which is why they charge more for it. But it's actually mostly Portland cement. But there are a few little additives that go into it. We actually use it from a box mixer. So you can use RMC. You could bring a truck right there, but the trucks would have to sit there for such a period of time. We actually just use it in super sacks. And we do a point mixing right there. But it adds a little additive. Most of it, honestly, is Portland cement and just extremely small aggregate. So it's a very good question. Yes, sir. So our code system doesn't have a concrete printing section. So each individual project has to be signed off by someone like myself as, an engineer of record. But that's the route we're going for right now. We do have the designs, they're already pre-designed. As you saw some of the test data, like it's incredibly strong. So we will go ahead and have pre-designed work and working with other engineers to be able to stamp those projects and move forward. Yep. Yep. So essentially they're adding an accelerant to cure faster because you have to have it curing within like 12 inches of layers for showing strength. So it's just sped up is all. So you typically can print the wall and you could load the wall probably within 2 days if you wanted to. But yeah, you just add admixtures to it. And it's really cool because, and I say it this way too, I've got 50 seconds left. The magic is not in the printer. The magic is in the design, and it's in the guy running the concrete mixer. Because the robotic arm just does this. I mean, I could put something over one of my guy's shoulders and run in a circle and have a concrete printer. It's the guy on the mixer who's watching the machine, who's seeing the powder go in, seeing the water mixture, and seeing the performance that makes all the difference. The other thing about it too is to realize that this technology is a job creation piece of equipment. It's a manufacturing unit that can do construction or products. And right now, it can run 24/7, so what you're looking at for every robot in Kentucky making concrete products or printing houses, it creates 12 to 15 jobs per machine. So thank you all very much. That was my time. I appreciate it. If you'd like to reach out, find Brian. He'll have my cards. Thank you.